The composition of magma determines how explosive an eruption is going to be. So, two things that can change this is the water content. So a volcano is more likely to erupt explosively if its magma has a high water content. So similarly to when you like shake a soda can and then it erupts. So what happens is you can kind of see a miniature version of this here in this GIF right here. As the lava gets poured onto the ice, right, it's rapidly causing all of the water there to quickly turn into a gas, and then those gases that are trying to escape makes it more likely to pop and bubble and burst, therefore creating it to be more explosive. Whereas silica works in a slightly different way. So silica is like rock particles. So the large percentage of silica causes explosive eruptions because since it's so thick, it causes the vent, the central vent at the top, to sometimes get plugged up, and then it builds up the pressure, and then it could be a really huge eruption that comes afterwards. So that is just another type of way that it could be super explosive. Now, talking about the top blowing off, this is what's known as a crater. A crater is a funnel-shaped pit that's formed around the central vent of a volcano. It's at the summit. This is important. Notice that all of these volcanoes are sticking out of the ground here, but then at the very top there's like this dip underneath. And here's one that has filled with like very blue looking, interesting looking water that has seeped in. Groundwater can seep into a crater at times. You could see another example of a crater up here. Now, this is different from what's called an impact crater. If you look at the moon, they have tons of craters on the moon. And it's not formed from active volcanism right there because they're not sticking out and then have the indentation. They have been impacted by meteors or asteroids that have hit them in the past and have pressed into it. So that's a little bit different here. It kind of looks like that's what's happened at the top of it, but that's not how this was caused. So there are impact craters that can exist on Earth. But that's not the ones that we're talking about here. This was formed by a volcano that has since had a large enough eruption that its top has kind of blown off. Now, a caldera is what a lot of people think to be a crater, but it's different, and there is a distinct difference. This is a circular depression, so this is being pressed in, but instead of it being an impact, instead, the magma chamber here empties. So somehow, the magma chamber, probably from a big eruption, has taken place, and it can no longer support the weight of everything above it, so it sinks into it. So here you could see the crater, almost looks like a weird looking smiley face there. And then you could see right here the actual crater collapsing right here. Sorry, the caldera collapsing. It's very easy to mix up the two. But caldera is pressed into the ground and the crater is at the top of the volcano. There are three major types of volcanoes. So the cinder cone volcano is made entirely out of pyroclastic material. Now, every single one of the volcanoes is made out of the stuff that comes out of it. So the cinder cone volcanoes are made out of that cement, like, oh, I shouldn't say cement. It's more brittle than cement. So it's made out of this dust and gas and rock and ash that falls down. It has pretty steep slopes and then a narrower base. So it's not super wide. And they normally only erupt for a short period of time, and they erode very quickly because they're not cemented together by the lava. The lava is the one that actually acts like the cement. An example here would be Patagotin in Mexico. And then you could see that oftentimes they get those craters at the top because they blow their tops off, and then there's not enough stuff to keep it there contained. The next type is called a shield volcano. Shield volcano, I mean, if you look from a distance, look how wide this base is. This has like the widest base. I like to imagine that there's like some kind of a giant that's picking this up out of the ground and using it like a shield. It's built out of layers of non-explosive eruptions, so just the runny lava spread out over a very wide area. It can be very, very large, but they're not often very steep. So all of the Hawaiian Islands here are shield volcanoes. And you could see some of the runny lava trickling down along the sides right there. And you could see that from a distance right there how wide it is. So that is your shield volcanoes. Two more examples of the runny lava spreading out over a long period of time, building upon itself very slowly, but never going straight up too high. Now, the final type is called a composite volcano. Composite, if you ever heard of a composite sketch before, sometimes like a police artist will do that. Somebody will say, oh, the criminal had green eyes, or he was this tall and had this beard or this facial feature. And then they'll take all that information, add it all together, and it's like a combination of all those things together. So a composite volcano is the same idea. It's both of the qualities of the last two volcanoes combined. It's often sometimes also referred to as a stratovolcano. Strato, always think of like strata, like layers. You could think of the stratosphere, that's a layer of the atmosphere. Strata is a type of thing that's found in rocks as well. Stratus clouds forms in layers. So forming alternating layers of pyroclastic material, like the cinder cone volcano, but also from the lava, just like the shield volcano. So it's like a layer of both. You have the, let's say, pyroclastic material, lava, pyroclastic material, lava, pyroclastic material, lava, all the way up. It has broad bases, and it gets much steeper towards the summit. And it's generally some of the larger volcanoes that you will see as well. Some of the most classic ones are composite volcanoes like Mount St. Helens and Mount Fuji in Japan. Here's just a fun picture of a explosive eruption. Now this, if you weren't clear, this is both explosive and non-explosive. You could see the lava, but you can also see the pyroclastic material, and you can see that as the warm air rushes upwards into the cold air that's around there, that friction generates the heat lightning as it moves up. Here's a very exaggerated version of that. Most people that have seen this said they don't think it's real. I don't know if it's real or not. I'm open-minded that it could be. Who knows? And then this is a interesting video showing a full day what it's like in Pompeii. You can skip forward through this. You don't have to watch the entire thing. I generally don't, but it just shows like a computer animation of what it was like way back when this nearby volcano did erupt. And so much literature and famous things have been based on this. Probably one of the arguably the most famous eruption that ever took place.